Welcome to Geometry Pre-AP. Today we're going to talk about dilations. So let me remind you to put this at the top of your notes. You'll need the vocabulary written in for today, which are all of these things. And of course the essential understanding question also. So please make sure you get all these things in your notes. Make sure you read them. Today's we'll be talking about transformations that are non-rigid. That means that they're not congruent. They don't preserve the measure. The angles are still preserved, usually, but not always the case. All right. So the first concept is a dilation. A dilation with a center of a dilation here. So we're going to use C as the center of our dilation. And we have a scale factor, which is N. And so N has to be greater than 0. We don't have negative dilations, so it has to be some sort of value that's bigger than 1. It could be fractions, could be numbers bigger than, could be less than 1, but it has to be bigger than 0. All right, this is a notation. I don't really use that notation. I'll always tell you it's dilation, and I'll tell you where to dilate about and what factor to dilate about. So the image of C, if we did a dilation, would still be at C no matter what our dilation is. And for any other point, so if we have R and we dilate it some scale factor like greater than 1, then R would prime would be out here. And so P would move to P prime and Q would move to Q prime. And so that would get our image from our pre-image of PQR. If you don't know the factor that we dilate about, the scale factor, you could take the distance from CR, which it says right here, to find N. It's from C to R prime all over C to R. So the distance from the center to the image over the center to the pre-image will get you that scale factor. Okay. Dilations do preserve angle measures though. So the angle measure is still the same. If you have some sort of weird manipulation of a dilation, which you're adding and multiplying, then sometimes the shape does change and the angles will change. Okay, so if we're looking here and it says here, determine the scale factor for the dilation, we want to see what the factor would be because it's not told to us. We know that if this is 15, this would be 6 right there. And so the distance from C to P prime is the first number, so from the center to the image, so that would be 6, over the center all the way to the pre-image, which would have been 15. And so when I reduce this, I get 2 over 5. And so we can see here this was a reduction, 2 to 5, the x value is 6. We know it's a reduction also because the original figure was large and the pre-image was large and the image is smaller, so therefore we have a scale factor that's less than 1. Okay, and so you can try this one right over here. I'll leave this one for you to do. And then if you need to, you can check your answer when you come to class. Okay. So again, here's some more. Find a scale factor. So I'll let you do these here also. If you have any questions about these, just let me know. Pause the video and start back up when you're done. All right, and so I'll let you check one of these here real quick. I'll give you the answer to the first one, which is A, and here is an enlargement of 3 over 2. All right, so for dilations that are centered at the origin, you can find the image of a point, so any point like P, point P, which is x comma y, by multiplying the coordinates of P by the scale factor. So when we look at this, it's going to be xy changes to nx comma ny, or whatever you have that you want to use for a scale factor here. This book uses n, other books have used k. So you just multiply each coordinate, whether it be a fraction or a whole number, and that'll get you where the new point. As long as it is at the origin. That's the key there. If it's not the origin, there's a whole entire process to that, and we'll be going through that. Okay? Now, you do not need to copy any of this. I will highlight this here for you. You don't need to copy this. This is what you can go back to and look at and read if you'd like to. if you're having problems with my method. Remember, I like to work smarter, not harder, and so it's another way you can just deal with things. I think this way is confusing, by the way. All right. So, what are the coordinates of the vertices of the dilation of PZG? Graph the image of triangle PGZ. So, as we look at this one, identify the coordinates of each vertex. The center of the dilation is the origin, and the scale factor is 2. So we're dilating about a factor of 2. So we take each one of the points, and we multiply the x and the y value by 2, and so we get 4, negative 2. Negative 2 times 1 is times 2 is going to be negative 4, 2. And then we do the same thing for the next order pair, which is 0, negative 2, which gives us 0, negative 4. And so then we graph those points. And so then this is our image right there. And now it was centered at the origin, which makes this one easier, just multiplying the points. So here's another practice one. This says dilation with the center at the origin and a scale factor of 1/3. So pause the video and do this one. Okay, so when you're done, this should be your answer. Now, there's a few things missing on this. You should have your points labeled, and they should have prime numbers by them, so please make sure you put those in there. I didn't want to junk up the screen too much when I was originally typing this out. All right, so dilating a figure without using the rules. Okay, we're going to dilate this about this point right here, which is the point. We're dilating about the point -8, -8. So -8, comma, -8. All right, so our first step, okay, is to draw the dilation lines. So that means take a ruler or take your ID or something like that, and we're going to draw some lines here. I'm going to use a color here, okay. Let's see, I want it to be a pretty thin line. So I'm going to dilate from this point right through there. So I want to draw a line from the point of dilation through the vertex for each point of the figure. And these are my dilation lines, okay? That means the new figure will have to be somewhere on these lines that I've drawn, okay? And so our next step would be to use the lines to determine the slope from the center to each point. So if I look here, the slope here would be 1, 2, 3, 4 up, and 1 to the right, so that's 4 over 1. The slope here would be 1, 2, 3 up, and 1, 2, 3, 4, 5. So 3 up and 5 to the right. And this one, the slope would be 0 over 4. Now I know that's a slope of 0, but I need to know those numbers. All right. Now, once I have this slope, if we're going to do a k of 3, then I have to do that slope 3 times. So 4 over 1, there's 1 time. 1, 2, 3, 4 up and 1 over, there's 2 times. 1, 2, 3, 4 up and 1 over, that's 3 times. So there's my point. I have to do 3 over 5. So this is the first time. 1, 2, 3, 1, 2, 3, 4, 5. There's the second time. 1, 2, 3, 1, 2, 4, 5. There's the third time. So this is the point I need. This was the point I need. And so 0 over 4, that's the first time. 1, 2, 3, 4. There's the second time right there. 1, 2, 3, 4. There's the fourth time. So now I've got all those points. Take my little tool here. I'm going to connect this point to this point to this point, and then that point to that point. And there is the dilation of the figure to a scale of 3. Now, if I wanted to do this to a scale of 1/2 or 0.5, I would not take the slope, but I'd take half of the slope. And so here we can see that there's the factor of 3, and this one was 1/2. Remember that the slope here was 4 over 1, so half of that would be 2 over what? 0.5? So 2 up and a half over would be here. This slope right here was 3 over 5, so half of 3 would be 1.5, and half of 5 would be 2.5. So that would be rise over 1, so 1.5 up. Oh, I'm sorry, I did that one backwards, didn't I? 1, 2, 3 up, and 4, 5. Yeah. Okay, so 1.5 up, so 1.5 up is here, and then 2.5, 1, 2.5 would be over here. Would be this one. And remember, this one was 0 over 4, so half of 0 is 0, half of 4 is 2, so 2 up, and so there we go. And so the green triangle there is for a factor of 1/2. So really, when you're dilating about a point that's not the center, it's probably easier just to draw those lines of dilation and just do uh, a number times the slope to get where your new points will be. Okay, so practice these two. See how you do on these. Pause the video and do these. All right, there's your 1/2, and there's your 4. Okay. All right, so now that you've seen these, if you have any issues with this, you can ask when you get to class. You can start working on pages 18 through 20. Dilations, the graphs are a little strange. Watch the scale on them. You might want to do them on your own graph paper. It might help you. Scales will be a little bit easier for you to follow. And that's the end.